In this video, I will talk about trig identities. So in grade 12, it introduced three other trig identities. That is the reciprocal of sine, that is called cosecant, and the reciprocal of cosine, that is secant, and the reciprocal of tangent, that is cotangent. These three didn't use quite a lot, so you can basically memorize it, or sometimes the teacher will give you a table. And the most important thing here is the Pythagorean identity, this one. So we have sine squared plus cosine squared is equal to 1. These two not used a lot, so if you can memorize, that's good. If not, it's okay. Sometimes the table will be given. And here there are sum and difference identities to simplify expressions and to determine extra trig values of some angles. So we have trig sum identity, that is sine A plus B equal to sine A cosine B plus cosine A sine B. And the cosine A plus B is equal to cosine A cosine B minus sine A sine B. So these two is very important. I hope you can memorize it. The teacher may give you the table, but it's good to memorize it. This one, the tangent, you can memorize it, or if not, you can just use sine over cosine to calculate it. So the difference identity just it's a variation of this one. So actually, sine A minus B, you just substitute minus B to here. So substitute minus B to B. As we might know, cosine theta is equal to cosine negative theta, right? Cosine theta is equal to cosine negative theta. So here is sine A cosine B, and but sine theta is to negative sine theta. Sine negative theta is equal to negative sine theta. So here sine negative b will equal to negative sine b. So if you know the some basic of trigonometry, these two actually you don't need to memorize, right? So sometimes I just memorize these two, and the rest I can denote by myself. And the double angle identity is basically you can represent A to here. So we have sine 2A is equal to sine A cosine A plus cosine A sine A. That's why it's 2 sine A cosine A. But this one is pretty easy to memorize. So for cosine 2A, again, you can put A to here. So it's cosine A squared minus sine A squared. These two used quite often, especially in calculus. So I also recommend you at least memorize these two. And this one is just a memorize. It's just a variation of the first one, because sine A is basically 1 minus cosine square. And if you open the bracket, it becomes this one. Or if you change cosine A into 1 minus sine square A, you will get the second one. But the good thing of the second one is it's all in cosine, and this one is all in sine. And the tangent one, again, you can put A to here, or you can denote by sine over cosine. So how it is used? So first, we can determine the exact value of each expression. So take this one for example. Without using a calculator, we know pi over 12 is 180 minus divided by 12, that is 15 degrees. So basically, we are looking for sine 15 degree without a calculator. So yeah, we can use the difference identity, right? So because pi over 12 is equal to pi over 4 minus pi over 6, So we can use a different identity, sine, cosine minus cosine, sine, and these are special angle because the reason why we use pi over 4 and pi over 6 because they are special angle. It's 45-degree angle and a 360-degree angle. So we know the value of the special triangle, right? So after calculation, we can get the exact value. And if you put into a calculator to verify, you can find the decimal value of it. So you can try with the calculator to verify it. Another example is solved by substituting trig identity and factoring. So you need to be able to solve these kind of questions. So for example, this one we have to find x from 0 to 2 pi. So here we have cosine 2x, and basically we need to change this one into a grade 11 grade 2 parabola. So we know that cosine 2x can change into 2 cosine square minus 1. And here it asks why cosine 2x chosen. Because cosine 2x can basically change into 3 different things, right? In our previous examples. And here, because we have a cosine x, and after some variation, we have grade 11 quadratic function that we can solve. So then we factor it and get cosine theta either to 0 or to 1/2. And when cosine theta is 0, we have x equal to pi over 2 or 2 pi over 3. We can solve this by draw a draft of cosine function and find the value of 0. For cosine x equal to 1 over 2, again, it's 1 over 2, right? And you can 1 over 2, so it's either in quadrant 1 or quadrant 4. In quadrant 1, it's 60 degree, so pi over 3. In quadrant 4, it's 2 pi minus the reference angle. It's 5 pi over 3. So this really depends on your skill in the previous chapter. So we have 4 solutions here. So this problem is solved. Okay, thanks for watching.